Welcome to The Explainer. Today, we're diving into a pressing and honestly inescapable reality that you've almost certainly noticed lately. Our summers have fundamentally changed. Across the globe, summer really isn't just a season of hot weather that we can casually enjoy anymore. Instead, it's morphed into something else entirely, a period defined by extreme, prolonged, and frankly highly dangerous heat events. In this explainer, we're going to unpack the exact science behind this massive shift. We'll look at why it's happening, why it matters so much to your daily life, and what it actually means for our shared future.
So, let's start by validating what you've likely been feeling these past few years. You aren't imagining it. The old normal of historical summers, the ones with rare, isolated heat waves and totally predictable seasonal peaks, is gone. Today, we are living in a completely new normal, one that's characterized by relentless, prolonged extremes. Temperature records aren't just being broken anymore, they are being absolutely shattered and with alarming frequency. The baseline itself has shifted into dangerous territory, which means today's heat waves last much longer, they peak much hotter, and they blanket much larger geographic areas than they ever did in previous decades.
Section 1. Amplifying the heat, your local reality. Before we zoom out to the whole planet, we need to talk about the urban heat island effect, because our built environments drastically change our local temperatures. Think about city centers. They are packed with heat-absorbing concrete, dark asphalt, and waste heat pouring out of vehicles and air conditioners. Because of this, a city can be a staggering 5 to 10 degrees Celsius hotter than the surrounding rural areas. Because cities severely lack natural vegetation, they completely miss out on evaporative cooling, effectively trapping the heat. And to make matters worse, those nighttime temperatures in urban centers stay super high, which completely prevents our bodies from recovering from the daytime baking.
Now, to truly understand why this heat feels so incredibly oppressive, we have to talk about wet bulb temperature. This isn't just about what the standard thermometer reads. Wet bulb is a crucial metric that combines both heat and humidity. See, when moisture levels in the air get incredibly high, human sweat simply can't evaporate. That high humidity, combined with the nighttime warming and urban air pollution we just talked about, literally pushes the human body beyond its physiological limits. It makes even modest temperature increases incredibly, sometimes lethally dangerous.
Section 2. The global warming engine. Okay, so zooming out, the absolutely crucial point here is the seemingly small number, 1.1 degrees Celsius. Multiple independent data sets all confirm that the Earth's global average temperature has risen by more than 1.1 degrees since pre-industrial times. I know, it sounds minor, right? But in planetary physics, it's absolutely massive. This warming trend shifts the entire climate distribution upward. Because our baseline temperatures are already elevated before the summer season even kicks off, extreme heat becomes statistically so much more likely.
And this brings us right to the main engine of all this, the enhanced greenhouse effect. Naturally, the Earth absorbs sunlight and re-emits it, but human activities like burning coal, oil, and gas, along with massive industrial agriculture and transportation networks, they pump enormous amounts of greenhouse gases into our atmosphere. We're talking carbon dioxide, methane, nitrous oxide. These gases act exactly like a locked door, trapping that re-emitted heat and completely preventing it from escaping back out into space. The inevitable result? Global baseline temperatures go up.
Now, here is a truly staggering fact. The vast majority of all that trapped heat doesn't actually just sit in the air around us. Over 90% of that excess heat is absorbed directly by our oceans. Think about that for a second. This is such a critical piece of the puzzle because warming oceans directly increase atmospheric humidity, which, as we just learned with the wet bulb temperature, is exactly what makes the heat feel so much worse. Plus, all that ocean heat fundamentally disrupts global weather systems, triggering massive events like El Niño, which are notorious for causing huge global temperature spikes.
Meanwhile, back on land, we are actively dismantling the Earth's natural air conditioning systems. Large-scale deforestation in vital regions like the Amazon, parts of Africa, and Southeast Asia literally strips the planet of its ability to cool itself down. Forests naturally absorb CO2 and release moisture through evapotranspiration, which cools the air and keeps local climates stable. When we chop them down, carbon absorption plummets, local temperatures spike, and entire regional rainfall patterns get severely thrown out of whack.
Section 3. Accelerators, climate feedback loops.
Here is the terrifying reality about climate change. It is not a straight line. It accelerates. A perfect example of this is the albedo effect, which is a self-reinforcing mechanism. As global temperatures rise, ice naturally melts. Now, because ice is bright and white, it does a great job reflecting sunlight away from the Earth. But as that ice disappears, it exposes darker surfaces like open ocean or bare land.
and those darker surfaces absorb the heat instead of reflecting it. That absorption causes even more warming, which then melts even more ice. It's a vicious runaway cycle. And we're seeing similar feedback loops happening everywhere right now. Drier soils lose their evaporative cooling properties, which just causes the ground to heat up even faster. At the exact same time, this extreme dryness acts as kindling, fueling massive wildfires. Those fires then release enormous amounts of trapped carbon dioxide straight back into the atmosphere, creating, you guessed it, even more warming. These feedback loops are exactly why the warming we're experiencing is accelerating way beyond many of the initial scientific predictions.
Section 4. The human and economic toll.
So let's bring this abstract science back down to reality. Rising temperatures are absolutely no longer just an environmental issue. They are a severe, immediate public health threat. Extreme heat is driving up mortality rates through heat stroke, cardiovascular stress, and outright kidney failure. It severely worsens respiratory conditions. And the saddest part? This burden falls heaviest on our most vulnerable populations. We're talking about the elderly, young children, individuals with chronic illnesses, and outdoor workers who literally cannot escape the blazing sun.
And beyond the direct hits to human health, the societal cascade is just massive. When temperatures spike, electricity demand surges because everyone is blasting their air conditioning, right? This leads to severe power grid stress and rolling blackouts. The heat destroys agricultural productivity, leading to major crop failures and critical water shortages in regions that are already bone dry. Economically, labor productivity takes a nosedive. Ultimately, all these compounding, crushing pressures force climate-driven migration, displacing entire communities.
Section 5. The path forward.
The scientific consensus on all of this is rock solid. Climate models universally project that if our current emission trends continue as they are, we are looking at even longer summer seasons and rapidly expanding regions dealing with incredibly dangerous heat days. Let's be clear. Without significant mitigation efforts, our summers are just going to keep getting more dangerous. We are even facing the very real risk of human unlivable heat conditions in certain parts of the globe.
However, it's not hopeless. We actually have a very clear blueprint for action. We have mitigation and adaptation strategies at our disposal across every level of society. Globally, we absolutely must transition to renewable energy sources, think solar and wind, and we need to aggressively implement carbon capture technologies. At the urban level, our cities can adapt by dramatically expanding green spaces to fight off that heat island effect and by using reflective building materials. And at the individual level, practicing basic heat awareness, like staying hydrated and staying out of peak sun, remains totally vital for everyday survival.
What we're experiencing right now is a fundamental structural shift in our Earth's climate system. Truly understanding the science behind these increasingly deadly summers is the very first step towards surviving them. But it leaves us with one final, absolutely critical question moving forward. Are we simply going to try to adapt to this highly dangerous new climate reality, or will we actually step up and take the actions necessary to change its trajectory? Thanks so much for joining me for this explainer, and please, stay cool out there.